The Pacific Ocean floor shifted on March 24, 2026, and what followed wasn't silence. It was the beginning of something that seismologists are still trying to fully understand. 50 aftershocks, more than 50, and they're still coming. Somewhere beneath the South Pacific, in one of the most geologically violent places on Earth, the ground decided it wasn't finished moving. And for the 100,000 people scattered across 171 islands in the Kingdom of Tonga, that decision wasn't abstract. It was felt in cracked walls, in the sudden rush toward higher ground, in the trembling of a beachfront hotel that refused to fall. This time. What happened beneath Tonga's waters on that Tuesday evening is more than a single earthquake. It is a window into a system that never truly rests. And what that system is telling scientists right now is something none of them are ready to dismiss. At 0437 Coordinated Universal Time on March 24th, which translated to early Tuesday evening local time in Tonga, the seafloor along the Tonga Trench lurched. The magnitude was confirmed at 7.5 by the United States Geological Survey, making it the largest earthquake recorded anywhere on Earth so far in 2026. The epicenter was located approximately 272 kilometers north of Nuku'alofa, Tonga's capital, and roughly 153 kilometers west of Niuefu, the archipelago's second largest town. The shaking reached Mercalli intensity levels between 5 and 7 near the epicenter, which on a practical scale means objects fell from shelves, walls cracked, and anyone standing felt the ground move in a way that removed all doubt about what was happening. At the Tanoa International Dateline Hotel, a beachfront property in Nuku'alofa, the building shook hard enough that staff and guests noticed immediately. But it held. No structural damage was confirmed there. That relative calm at the surface, and however, concealed something far more complicated underground. Within minutes of the main shock, the USGS and NOAA's Pacific Tsunami Warning Center were already processing data from seismic stations across the region. The initial question, as it always is with a high-magnitude Pacific earthquake, was whether a tsunami was coming. The answer came quickly. No tsunami warning was issued by the USGS, which noted the earthquake was located too deep inside the Earth to generate a significant tsunami. NOAA confirmed that any ocean displacement was minimal, with wave heights measured at less than half a meter. The Tonga Meteorological Service did issue a brief precautionary tsunami warning for local coastal areas, but that warning was lifted approximately 2 hours after the main shock. New Zealand's disaster management authorities confirmed there was no tsunami threat to their country, roughly 1,800 kilometers to the southwest. But before that official all clear arrived, Tonga's National Disaster Risk Management Office was already pushing warnings through every available channel, including Facebook, which in remote Pacific Island communities functions as a primary public alert system. Residents were told clearly, move away from beaches, shorelines, and low-lying coastal areas. Move to higher ground, move inland, do it now. Evacuations took place across the northern Tonga Islands. Most residents returned home within hours after the tsunami warning was lifted. There were no confirmed deaths, no confirmed injuries, and no reports of major infrastructure damage, though satellite shake map data from Geoscience Australia indicated light damage to homes in the Vava'u Island group. Cracked walls, objects displaced, the kind of minor structural evidence that tells you the shaking was real even when everyone walks away. Power remained stable across the main island of Tonga Tapu. Clinics were monitoring for minor injuries but reported nothing overwhelming. The Red Cross was placed on standby. New Zealand and Australia both confirmed monitoring support. Emergency supplies had been prepositioned in Nuku'alofa. By any traditional measure of disaster response, this was a contained event. No one died. The infrastructure held, but that's only part of the story. Because while the headlines said no deaths, no tsunami, the seismic record told a different story, one written in the language of aftershocks, and it was a language that did not stop speaking. Within the hours following the main shock, the USGS cataloged multiple aftershocks. These ranged from smaller magnitude events up through a strongest recorded aftershock in the mid-5 range. 3 smaller earthquakes were recorded almost immediately after the main shock. Not unusual for a 7+ event, but in this case the swarm character of the sequence was notable. These weren't simply the standard mechanical readjustment of rock under new stress. The swarm was dense, sustained, and geographically spread in a way that suggested the initial rupture had redistributed stress across a broader section of the fault system than a single clean break would imply. The USGS Aftershock forecast model, which calculates probabilistic outcomes based on the main shock magnitude and initial swarm behavior, placed a 20% probability on at least one additional magnitude 6, or greater aftershock occurring within the ongoing swarm sequence. The forecast window extended 1 to 2 weeks. 20% sounds manageable. But in seismic science, a 1 in 5 chance of a major secondary earthquake is not a number that allows anyone to sleep easily, especially when the population at risk is spread across dozens of islands with older building stock that the USGS has flagged as structurally vulnerable to repeated strong shaking. The Tonga Trench is not a passive geological feature. It is one of the most extreme subduction zones on the planet, a place where the Pacific Plate is being consumed by the Earth at a rate that produces earthquakes with startling regularity and power. The trench itself reaches depths of more than 10 kilometers, making it one of the deepest ocean trenches in the world. The subduction dynamics here are not subtle. They are continuous, powerful, and capable of generating not just earthquakes, but tsunamis, volcanic eruptions, and the kind of chain reaction geological events that reshape coastlines. Tonga sits directly on the Pacific Ring of Fire, the roughly 40,000-kilometer arc of subduction zones and volcanic systems that encircles the Pacific Ocean and accounts for approximately 90% of the world's earthquakes. Within this ring, Tonga and its neighbor Fiji are consistently ranked among the most seismically active nations on Earth. This is not a region where large earthquakes are anomalies. They are expected. They are built into the geological identity of this place. What makes the March 24th event scientifically significant is not simply its magnitude. A 7.5 is serious, but not unprecedented here. What matters is the depth of this earthquake, which the USGS placed at approximately 230 kilometers below the surface. This classifies it as a deep focus earthquake, one occurring far down in the subducting slab where rupture dynamics and tsunami generation work very differently than in shallow events. That depth is precisely why the Pacific Tsunami Warning Center determined no tsunami threat existed. The energy source was simply too far beneath the ocean floor to efficiently displace the water column above it. Deep focus earthquakes can still produce intense shaking at the surface, but their energy propagates through the Earth in fundamentally different ways than a shallow rupture along the upper portions of the fault system. What scientists can say with certainty is that the Tonga Trench has a documented history of producing exactly this kind of event, and that history is not reassuring. In 2021, a magnitude 8.1 earthquake struck the Kermadec Islands region, south of Tonga, in the same broad tectonic system. It generated tsunami advisories across the Pacific and sent a clear reminder that the subduction machinery beneath these waters was operating at full capacity. Before that, the historical record is punctuated by high-magnitude events across this zone, data points in a pattern that shows a fault system under sustained, accumulating stress, releasing that stress in periodic high-magnitude events, and then cycling through the swarm sequences that redistribute whatever stress remains. The aftershock swarm from a major earthquake doesn't just shake the ground, it interrogates the surrounding fault system. Each aftershock tests adjacent sections of fault that are now under altered stress conditions. Sections that may have been close to their own failure thresholds before the main shock moved the tectonic puzzle pieces around them. This is why seismologists watch swarms with such focused attention. The swarm isn't just noise following the main event, it's information about what might come next. And now, scientists fear history may be repeating itself, because the most powerful reminder of what this corner of the Pacific is capable of came not from an earthquake, but from the sky. On January 15, 2022, the Hunga Tonga Ha'apai submarine volcano erupted in what scientists would later describe as one of the most violent geological events of the modern era. The eruption plume reached an altitude of approximately 58 kilometers, breaching the stratosphere and entering the mesosphere, a height no volcanic plume had been confirmed to reach in the modern instrumental record. The eruption's main phase lasted approximately 11 hours and released 1.9 cubic kilometers of ejecta into the atmosphere and ocean. The explosive energy released was estimated to be hundreds of times greater than the atomic bomb dropped on Hiroshima. The pressure wave from the eruption circled the Earth multiple times, detected by weather stations on every continent. The tsunami generated by the eruption killed at least 4 people in Tonga and claimed additional lives as far away as Peru, sending waves across the entire Pacific basin. Coastal flooding was recorded as far away as Peru and Japan. The blast destroyed the island's above-water structure almost entirely. Satellite imagery showed a landscape transformed overnight, reefs exposed, islands reshaped, communications cables severed, leaving Tonga isolated from the outside world for days. That eruption did not come from nowhere. It came from a volcanic system embedded in the same tectonic framework that produced the March 24th earthquake, the same subduction zone, the same Pacific plate descent into the Earth's mantle, the same chain of geological consequences that flows from one of the most seismically and volcanically productive regions on the planet. No one is currently suggesting that this earthquake is a direct precursor to another eruption of that magnitude. The scientific record does not support that specific claim. But scientists do note that in heavily active subduction zones, the relationship between large earthquakes and volcanic unrest is real and documented. Seismic energy can alter pressure conditions in magma chambers. Stress changes in the crust can open or close pathways that influence hydrothermal and volcanic systems. These relationships are probabilistic, not deterministic, meaning they create elevated risk landscapes, not guaranteed outcomes. But in a place where a volcano already demonstrated in 2022 what it is capable of, that risk landscape is not theoretical. It is written in the geological record of these islands. And the Earth just reminded everyone that the record is still being written, because what happens next could rewrite maps. As of March 25, 2026, Tonga's National Emergency Management System remains activated. The state of alert declared by the Prime Minister's office is in effect. New Zealand and Australia are continuing their remote monitoring support. The Red Cross remains on standby. The USGS Aftershock forecast is being updated as new data arrives, and the seismic network beneath the South Pacific continues to register activity. Magnitude after magnitude, each one logged, each one analyzed, each one added to the growing data set that scientists are using to try to understand what the Tonga Trench is doing right now. The human exposure in this event was kept low by geography. Tonga's archipelago of 171 islands has a total population of approximately 100,000 people. The majority live on the main island of Tonga Tapu, which was not the closest inhabited area to the epicenter. The Vava'u island group, where light structural damage was reported, sits closer to the zone of strongest shaking, and it is in places like Vava'u, remote, with older building stock, dependent on inter-island logistics for supplies and medical care, where a more destructive sequence of aftershocks would have its most concentrated impact. The financial damage from this event is currently estimated at less than $5 million. That number will be refined as assessment teams reach outer islands. It is a number that, by the standards of major earthquake disasters globally, looks almost inconsequential. But it reflects the current damage, not the potential exposure if the aftershock swarm produces that 20% probability magnitude 6 or greater event in the coming days, and not the cumulative vulnerability of infrastructure that has now been stressed, even lightly, by repeated ground motion events since the main shock. NASA's Earth Data Program, using Sentinel-1 synthetic aperture radar satellite imagery, has so far detected no surface rupture, meaning the faulting did not propagate to the surface in a way that would create visible ground breaks or large landslides detectable from orbit. That is a partial reassurance, but it also means the full geometry of the rupture, exactly which fault plane moved, how much, and in what direction, is still being modeled from seismic waveform data alone. That modeling takes time, and until it is complete, the picture of what exactly happened beneath the ocean floor on March 24th remains partially obscured. Scientists at the USGS, Geoscience Australia, and partner institutions are working through that data now. What they know is this: a magnitude 7.5 earthquake in one of the world's most seismically active subduction zones has produced an ongoing aftershock swarm. The swarm has a statistically significant probability of including at least one additional major aftershock. The local population evacuated returned and is currently in a period of waiting, watching for the next tremor, listening for the next official message pushed through a government Facebook page in a region of the world where that is the fastest way to tell 100,000 people that the ocean might be moving toward them. And beneath all of it, the Tonga Trench continues its ancient work. The Pacific Plate descends. The subducting slab bends and fractures under unimaginable pressure. Magma rises through pathways carved by millions of years of geological violence. The aftershocks continue to arrive, smaller now, but not gone. There is a question that seismologists always ask after a major swarm begins, and it is a question that has no clean answer yet. In this case, is the largest earthquake in this sequence already behind us, or still ahead? The USGS 20% probability of a further magnitude 6 or greater event means 80% of the modeled outcomes say the worst has passed. But 20% is not nothing. In a swarm this active, in a zone this productive, that remaining probability will not drop to zero for days. Every night that passes without a major aftershock narrows the window. But the window has not closed. The answers are in the data. The data is being processed. And somewhere beneath the South Pacific, in water, more than 10 kilometers deep above a trench that has been pulling the Pacific Plate into the Earth's interior for tens of millions of years, the ground is still moving. Stay safe, stay curious, and keep your eyes on the Earth.